So we want to rewrite the quantity as an algebraic expression of x and then state the domain on the equivalence that makes it valid. So let's look at this one, and I have the sine of the inverse cosine of 4x. So I'm going to draw a triangle and label the sides of the triangle so that the cosine of that triangle is 4x. So I'm going to make the triangle. Cosine is adjacent over hypotenuse, so I'm going to label that 4x, and it's not a fraction, so I can make it a fraction by putting it over 1. So adjacent is 4x and hypotenuse is 1. And so now I'm going to find the missing side, 4x, we need that whole quantity squared, plus I'll call it b squared equals hypotenuse squared. So b is going to be 1 minus 16x squared and square rooted. So let's go ahead and put that in, square root of 1 minus 16x squared. Get this out of the way so we don't get that confused. Now, as I look at this, then what I need is this triangle represents this angle theta, and I need the sine of theta. So I need opposite, which is square root of 1 minus 16x squared, over hypotenuse, and hypotenuse was 1, so I don't need to write it. So there is my answer. Now I also need to state the domain. So looking at this, we see that we have a square root, and so we need to restrict the domain because we cannot use x's that would make a square root a negative. So what I need to do is I need to say, well, the stuff underneath the square root cannot be negative. Well, greater than or equal to 0 are the numbers that are not negative. So let's figure out where it equals 0 and then figure out where we need to shade so that we cover all of the ones that will make the 1 minus 16x squared greater than or equal to 0. So I am going to factor that. That's going to factor into 1 plus 4x and 1 minus 4x, and I'm going to figure out where it actually equals 0 because those are the cutoff points, so those will be the ends of our intervals. So if I set the first factor equal to 0 and solve it, I get x equal negative 1/4, and if I set the second one equal to 0 and solve it, I get x equal 1/4. So what that means is from negative 1/4 to 1/4, either all of the stuff in between works or the two ends work. And let's try 0 that's in between. If I put 0 up here, I have the square root of 1, which is fine. And so I am going to shade in between. Actually, I'm going to get another color so you can see I'm shading in between. And it's okay to equal the ends because if I let it equal, for example, 1/4, when I put 1/4 in up here, by the time I square it, that's 1/16. 16 times 1/16 is 1. 1 minus 1 is 0. Square root is 0, 0. That's okay. So I'm going to put the answer right here. It is going to be the interval from negative 1/4 to 1/4, including the ends. So let's go ahead and look at our second one. And the first thing I see is this, it represents an angle, so that when I take the sine, I get 3x. So I'm going to draw a triangle, and I'm going to label the sides so that the sine is 3x. And so opposite is 3x over hypotenuse, which is 1. So that means a squared plus 3x squared equals 1 squared. So a is going to be 1 minus 9x squared square rooted. So that's my missing side, 1 minus 9x squared. Now, going back to my original problem, I need the secant of that angle. The triangle represents that angle. And so we know secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So the one I want is hypotenuse over adjacent, the reciprocal. So that's going to be hypotenuse over adjacent, which is square root of 1 minus 9x squared. So that is my answer, but I need to now think about the domain. I have the two illegals can both happen. I can square root a negative, so I have to restrict x so that doesn't happen. But also because this radical's in the denominator, if that radical equaled 0, I'd be dividing by 0. So I need to restrict it so it cannot equal 0 in the bottom as well. Well, if we went to figure out when it equals 0, that would be if I had 1 minus 9x squared equals 0. So I'm going to go ahead and factor that. That will factor like this. And figuring out when that equals 0, that would be at negative 1/3 or at 1/3. So I know that I'm going to have values from negative 1/3 to 1/3, and putting in 0 works, so I know it's going to be the values in between. But unlike the last problem, I'm not going to square the ends, because if it equaled the ends, I would be dividing by 0. So I need to round the ends, and my interval then is from negative 1/3 to 1/3, not including the endpoints.